A dual wheel load assembly has 102 kilonewton on each wheel with tire contact pressure of 0.07 newton per mm square. A clear gap between the dual wheel is 200 mm. Determine the vertical stress values at a depth of 500 mm at radial distance of 0, 130 to 60 mm from center line of dual wheel. Here, given data in that 102 is the given load, right? And clear distance between the inner wheels, that is 200 mm, and depth here is given at 500 mm depth, and radial distance here is given. R is equal to 0, R1 is R2 is equal to 130 and 260, right? At these points, we need to find this stress, right? So from capital P and contact pressure, you can find the small a, radius of contact area. Small a, you can find 215.36 Z by A. You can find that is 2.P2, and R by A, R values are there. So R by A chart, and Z by A. That for that we need to refer the chart, right? When we refer the charts, that time we'll come to know these values. So I'm just telling. So this Z by A, Z by A values here we'll see, and R by A. These are the lines with R by A values, different R by A values, right? So from those references, for example, this is 3, Z by A is 3, and R by A is equal to 2. So this is R by A is equal to 2 line. So here it is cutting. So with respect to this, what is the value here? Sigma Z by P. Sigma Z by P is 6. So sigma Z by P is equal to 6. We will be knowing small p. So sigma Z is equal to small p into percentage of whatever value of 6, 6 divided by 100. So like that you can find the sigma Z. Sigma Z for various R by A and various Z by A. That is what is being calculated here for different R by A and Z by A. Z by A is constant 2.3, and R by A is varying 0.0, 0.6, 1.2. So for that different values we found. There I had mentioned 6, no? Similarly 28, 24, 20. Then you have multiplied and got these stress values, right? If they ask you to draw the diagram, that also you should be able to draw. Okay, sigma Z one side and R values, uh, radial distances other side, and should be able to draw the diagram. Okay. So we'll take up the next